Okay guys, we're going to go over these 5 problems that you had. The mastery check number 1, you were supposed to solve 5 linear systems. You need to know that by solving a system using a graphing calculator, you're going to plug them into the graphing calculator in the y equals screen, and you are going to find their intersection. Key component that we're going to make sure we cover really well here is that you need to check them. Now, I glance at these and I see that neither one of them need to be manipulated because they're already solved in terms of y, which means they can go directly into the calculator. Go zoom 6, and you will see the standard window, which goes from 10 to negative 10 in both directions. Now, one of the things you're looking for is, can you see the intersection on the screen? Yes, we can. One of the other things you're looking for is, can I get a good estimate? Can I count out these tick marks? You want to go to Window and check the scale in each direction. The X scale is 1 and the Y scale is 1. What that means is that every tick mark is worth 1. So I would guess that this is 1, 2, 3 over, 1 up. So my guess is the point 3, 1. Now, you should not be satisfied. So what we're going to do is we're going to plug this point in. The x value is 3, the y value is 1. Plug into both equations and make sure you get a true statement. So we are going to plug a 1 in there, a 3 in here, and check, is it true? Is 3 minus 2 equal to 1? And obviously yes. Works for the first one, but it does have to work for both. Plug it into the other equation. 1, is that equal to negative 2 times 3 plus 7? And the answer will again be yes, because this is negative 6 plus 7, and negative 6 plus 7 is the same as 7 minus 6, and that does equal 1. It worked for both, therefore it is our answer. Number 2. Once again, we have neither equation needs to be manipulated. They're both solved for y. Y equals. There's nothing on the other side with it. Nothing being added, nothing being multiplied. So we'll bring the calculator back up. We'll go to y equals. Quick glance at the other problems will show that I don't need these exact same functions again, so it's fine to clear them from the calculator. No big deal if you did and needed them anyway, because they're quick to put back in. And once again, I'm going to get an intersection very close to where I had it before. This one looks like it's 2, 1, so that is going to be my guess. Then we plug in and check to see if it's true. Again, the x value is first, so that's here. The y value is second in the ordered pair. So the x is 2, the y is 1. Is 1 equal to negative that 2 plus 3? And it is. Plug it into the other one. 1. Ooh, that was messy. Mouse writing until I get something better. 1. Is that equal to 3 halves times, let's see, x value is 2 minus 2. I have a fraction. It looks like it's multiplying something that's not a fraction. So what we're going to do is we are going to make the thing that looks not a fraction like a fraction by putting it over 1. Then we're going to multiply straight across, and we are going to get 6 halves is 1 equal to 6 halves minus 2. And that is yes, because this is 3 minus 2. So it worked for both. So this one, as easy as the first one, our guess was right on. So on to number 3. Now in this one I have 2 equations that both need to be manipulated. So it's a little bit more difficult. So I'm going to separate them. We need to isolate the y, so we're going to subtract 2x from both sides. Now these two terms over here are not like terms. They're unlike terms, so they cannot be added. They cannot be simplified any further. So I'm going to write them in this order because that's what you are used to. Y equals mx plus b. We still have to get rid of this 4. You ask yourself, what is the 4 doing to the y? It's multiplying it. How do you get rid of it? You divide. So divide every single term by 4. And we get y equals negative 1/2 x plus 3. And we're done manipulating that one. To the purple one. This will be much easier. One step. Subtract x from both sides. So we get y equals negative x plus 2. And y equals negative 1/2 x plus 3. So we're going to plug those in the graphing calculator. Negative 1/2 x plus 3. Negative x plus 2. Graph. Okay, I'm going to guess negative 3, 3. And I need a little bit more room. So I'm going to plug it into this one first, because it looks a little bit easier than this one. So 3, is that equal to negative from here? Now I have an input, or an x value of negative 3. So I'm going to put parentheses around it, so that I can see those two double negatives separated by something. And you could read this as the opposite of negative 3. The opposite of negative 3 is positive 3, so that's 3. Another way to think about it is a negative times a negative is a positive, and a positive, well, when it's first, we don't write it. If it's second, that positive gets bigger, and it's a plus sign. All right, 3 equals 3 plus 2? No. So that means that our guess was a bad guess. That's supposed to be a big X for no instead of my check mark. So I'm going to show you how to get a better guess, and we'll actually use this from now on, unless it's really, really obvious. I hit the trace button, and you see the cursor is blinking right here. Also note in the upper left-hand corner it says y1 equals negative 1/2 x plus 3. That's the first function we had in here, negative 1/2 x plus 3. Hit trace again once I left that menu. I need to come back. Now you can use the up or down arrows to jump functions. If I go up, it goes to the y2, my second function, negative x plus 2. I could either go up to get to the next function or just keep hitting the same up or down arrow, and it will just toggle like a light switch, up, down, up, down, up, down, as I hit one direction or the other. To travel left or right, roughly, we're going to use the left or right buttons. You want to get close to this intersection, and then these numbers down here will give you an idea. Now note as you move, the numbers turn up to be decimal numbers, and the best you're going to do is get something like an estimate. So it looks like maybe negative 2, 4 would be my next guess. Negative 2, 4. Now plug that into the purple equation. I'm going to change pens here. And that will look like y is 4. So I'm using this one right here. Y is 4. And the opposite of negative 2. Opposite, x was negative 2 plus 2. So this will be 2 plus 2, and that does equal 4, so that checks out. Now I get to go to my green equation. Plug it in. So let's see. Y is 4. Is that equal to negative 1/2 times negative 2 plus 3. Negative times a negative is a positive. 2 times a half is 1. So this is 1 plus 3. Is that equal to 4? And the answer is yes. Therefore, negative 2, 4 is my answer. Okay, we are going to skip this one. Nobody got this one right on the first try. This was quite problematic, so we're going to come back to it last. So in this one, you've got one equation to manipulate and one you don't. Subtract 5x from the bottom equation, and we get y equals negative 5x plus 18. So the top equation is just going to be x. The bottom equation, negative 5x plus 18. And like last time, before I even guess, I'm going to hit trace, get close to that intersection, and use the numbers on the bottom to give me a good idea. That looks close to 3, that looks close to 3. So my guess is the point 3, 3. And checking the top equation, that's an obvious yes. Y equals x, 3 equals 3, yes. Plug it into the one on the bottom, 3 for y. Is that equal to negative 5 times 3 plus 18? I do this for is it equal to. Negative 15 plus 18 is positive 3. So I've got that answer. Back to number 4. Okay, the problem is this has no y in it, which means that this was going to be very difficult to solve with the graphing calculator. I'm going to put y, oh, I have to manipulate this one. It's not solved for y, it's solved for x. So I will add 10 to both sides. And it becomes x plus 10 is equal to y. So I plug that in the calculator as x plus 10. On paper, it doesn't matter whether this is left to right or right to left, but in the calculator it does. The y has to be on the left. Now, this equation, x equals 10, I have no option in this graphing calculator to change that to an x. So I'm going to make it y equals 10, which is not valid. It changes the problem entirely, but it's going to show you something in the graphing calculator. Here's the first one I put in, and here comes the second one. It is a horizontal line. It looks like this. Y equals some number is a horizontal line. X equals some number is going to be a vertical line. And I still can't graph that on the graphing calculator. But it would be right here, and my intersection would be right up here in the corner. Something I'm still not going to be able to get the graphing calculator to get me. But one thing I can tell is that in my answer, my x value has to be 10. Some people said they saw this after they turned it in. So I'm going to take that 10, and I am going to plug it in right here, and that says the y value must be 10 plus 10, which is 20. And we now have checked this. X equals 10, yep. And 10, let's see, plug it into here. Let's see. 10, is that equal to 20 minus 10? 10, is that equal to 20 minus 10? And the answer is yes. It checks out for both, so we have our final answer. Now on this one, folks, I didn't think about the difficulties you were going to have here, but I did think, maybe you would find a different way to do it by plugging that one in here. So, maybe I set you up a little bit. If in order to get 4 right on this one, you probably had to get 1, 2, 3, and 5 completely right. Problems like this will come up in the future, but I probably should take that out of this particular lesson. Okay, that's it.